Hi, my name is Marvin Bullock, and today I'm just going to show you this project that I've been doing for the last while, the capstone project. So right now I'm just going to start you on the HMI page, and I have 3 pages set up. So the first one is for processes, and in there you can be able to get the data in real time of what's going on, like when you note the numbers inside the page. Alright, so if I do another transaction, sales are going up, the inventory is going down. So when you get to those points, you'll get an alert, and you'll have to start doing the opposite. That's pretty much it. On the next page, the quality control. You can pull product off the line, and you can start your data logs, so you can do Excel spreadsheets. And then the last one, the administrative one, you can have inventory to reset or initiate data logs. Depends on which side you're on. So I'll go ahead and push the inspect product button. Yep, goes onto the conveyor, takes something out of it, and goes back. So that one was achieved using timer delays, and yeah, just coding with the timers, and you can be able to actuate that, because it goes forward, turns on the electromagnet, and then goes back, then turns off. Alright, and then we have the conveyor belts. So this side, once I initiate the conveyor system, I use clock bits to set the blinking lights, and the conveyor works, as you can see. This whole unit was designed on Autodesk and CAD it up, and then 3D printed. And then we're using a geared 12-volt motor, and it's DC. So with DC, it's beautiful. You can always control the speed by just altering the voltage. Right now, it's working well enough. Our product in the line, and it will go into storage. Alright, so that was one aspect of it. I'll move it to the next station. So that was the presented side, and this other side is where all the magic happens. And the nitty-gritty is not the most beautiful thing, but it works. So we have the relay here, which controls the motor, because the amperage and the voltage on this, and this side is still working on 24 volts offered by the Siemens, because I have my negative bus bar on this side and the positive at the top. But I want a way to control, for the logic of the PLC, to control a motor which on this end of the circuit is different voltage. So right now I'm running it on 4.5 volts, and that's the speed for the conveyor at the moment. And if I turn on this side of the relay using the PLC controls, the conveyor starts moving and the lights start blinking. And if I increase the voltage, note what happens to the motor drive. starts moving faster. So you can control the speed exactly how you want it. Alright, so turn that system off. So we talked about the actuated side, which is a spring cylinder which gets air from this air compressor, which is portable. So you can set the value of the valve at any point, and pressure gauge over there. So tweak the circuit to however how fast or how slow you want to actuate. And then here we have a single entry port for the pressure coming in, and then we have two relay systems here for the electric actuated controlled valves for the pneumatic system. So one sends air to the front part of the cylinder, so it'll make it retract, and the other one pushes air to the other side to make it extend. So it just depends on which side of the switch is on, and you can use code latching and unlatching certain sequences inside the code to achieve that. So this side of the board, which controls the main display, and then here we come to the PLC and the switch. So those two work in tandem to create a network. PLC on its own, I put all the inputs at the top, outputs at the bottom, and then ground to the DIN rail mount itself, and making the whole metallic surface ground, so if I need any ground, it's easy to pull it off. And then on the right side I put my 0 volts, and the other side I put my 24 volt positive. So that was it, and I'll explain to you more information of what really happens when I'm walking you through the code. Thank you.